So we achieved bending moment at xx is equal to minus WA by L into x. Now if we put x is equal to 0, means bending moment at A. My bending moment at A, which is equal to 0. When x is equal to L, because between this two there is not a single load is there, so this section is applicable between A and B. So for at L, bending moment at B is equal to minus WA, and this variation has been given by this relation WA by L into x. This equation suggests us inclined straight line. So we got 0 WA. This has been joined by inclined straight line, negative sign. See precisely what we achieve right now. Now we have to find out the variation of bending moment in this region. Obviously we have to take a section over here, and the diagram is there also with us, and that diagram is over here. This is the diagram. This is nothing but WA by L. This is W 1 plus A by L, and this is nothing but L. Let us say this is x. This distance is x. This is L, which is known to us. Our intention is to find out bending moment at xx. It will be found out. Bending moment at xx is equal to, this creates hogging, minus sign, WA by L bracket L plus x, because moment over here. We have to take a moment. What is moment? Moment is nothing but the force multiplied by perpendicular distance. This is my force, this is the distance which I got it over here. Another force is there, creates section left clockwise, which is of nature of sagging, plus W bracket 1 plus A by L into x. This is the also shows the equation of simple multiplication of x. This is also the equation of a straight line, and you just simplify this. This equation and put the value. When x is equal to 0, what happens? X is equal to 0 means bending moment over here. Bending moment at B, we got it. When x is equal to 0, this term which has been nullified, we got it minus WA. And if we take x is equal to A, when x is equal to A, then at C point, what is the bending moment? So bending moment at C is equal to, when x is equal to A, please check it out, it must be 0. So finally we achieve this value is 0. This is W into A value joining by inclined straight line. This diagram is known as the bending moment diagram. You can find out this part variation instead of taking slightly complicated equation. You may take a section from the right side. How? Let us be understood over here. How? Take a section from the right side. X, this is W. So bending moment at xx is equal to W into x. This creates section right clockwise, creates the hogging nature, negative sign. Now when x is equal to 0, bending moment at C is equal to 0, that we have achieved over here. And when x is equal to A, bending moment where it is at B over here. But bending moment is over because I have taken a section from here. So now bending moment at B is equal to minus WA, the same thing which we have when we got it over here, and joined by inclined straight line. So what is the basic rules that we observed over here? The first rule, important one, between 2-point load, if there is no load, the variation of bending moment which has been given by inclined straight line. That point we have been observed over here. So now see in this PPT, the similar diagram we have achieved over here in this PPT. So now I wish it is clear to all of you how to plot shear force and bending moment diagram specifically for a overhanging beam. Thus we proceed for the next problem, number 2. Now here also the given beam, yes, as we have discussed, or we are discussing a cantilever beam, overhanging beam we are discussing right now. Here the beam whose one end is projected beyond the support, obviously it is a overhanging beam, subjected to 2-point loads, 12 kilonewton from the support A from 1 meter and 8 kilonewton from support C, that is from 1 meter distance. It is 8 kilonewton which has been there. Now what is our intention? Our intention is to plot shear force diagram and bending moment diagram. So step number 1, we have to find out the support reactions. The support reaction we can find out with the help of equilibrium conditions. The first equilibrium condition, sigma h is equal to 0. As such, there is no load, horizontal load. RAH horizontal component is 0. That we can achieve over here. Sigma h is equal to 0, RAH is equal to 0. Sigma V, that is the another equilibrium condition, sigma V is equal to 0. Summation of all the vertical component of forces which are equated with 0. Visualize the two forces which are acting upward, that is we have assumed right now, that is RA and RC, the reactions. So RA plus RC, which is equal to total downward load, that is 12 plus 8. So we achieve a single equation, RA plus RB is equal to 12 plus 8 is equal to 20 kilonewton. So from sigma V, we are able to find out an equation which gives us the summation of the two reactions is equal to some value. So to find out an individual value of the reaction, we have to use the next third equilibrium condition, that is sigma m at a certain point which is equated with 0. That is, just take a moment at A over here which is equal to 0. Means we have to take the moments of all the forces, moments because of this 12 kilonewton, moment because of RC, moment because of 8 kilonewton, moment because of RA at E point, and then we have to equate with the 0. First, RA into 0 itself is 0 because we are taking the moment because of RA at a point where we are interested to find out the moment, because the perpendicular distance is 0 itself. Next, this 12 into 1 creates the clockwise moment, so plus 12 into 1. Next 8 creates a clockwise moment, so 8 into 3 plus 1 4, 4 plus 1 5, so 8 into 5, and next this load, that is RC, creates an anti-clockwise moment, RC into 3 plus 1 4, which is equal to 0. let us resolve this equation. By resolving this equation, we got RC as equal to 13 kilonewton, and by putting the value of RC in this equation, RA plus RB is equal to 20. So RA plus 13 is equal to 20. We achieve RA as 7 kilonewton. So we have the two unknown reaction right now, that is RA which is of 7 kilonewton, RC as of 13 kilonewton. And now our intention is to plot shear force and bending moment diagram with our basic concept. Let us go ahead on this tabletop. Distance is of 1 meter, 3 meter, 1 meter. The reactions which we know, that is of 7 kilonewton, 13 kilonewton, and the loads are 12 kilonewton, 8 kilonewton, and these are the sections, important sections, where the load has been applied, and this is our basic baseline. All the positive values are plotted above baseline, all the negative values are plotted below baseline. Now shear force. To plot a shear force over here, at A, this is my section P, this is my section D, this is my section D. Now at section A, 7 kilonewton is there. If we take a section over here, visualize, take a section over here, section XX. Seven kilonewton. My unbalanced forces 7 kilonewton. So my shear force remaining unchanged 7 kilonewton. Between these 2 points there is no load, remains same as of 7 kilonewton with the plus sign. Why plus sign? Because section left taken as a positive. Next, at B, so let us take a section over here. So my figure is of like this. Section XX, 7 kilonewton, 12 kilonewton. Net or unbalanced vertical force in this region is of upward 7, minus 12 downward, so 7 minus 12, 5, and at a point load the shear force goes suddenly changes 5. Between B and C, visualize very carefully, no load is acting. Means this section is applicable up to the point C. Hence the shear force at each and every point is of 5 kilonewton with the negative sign. So shear force diagram, which is of horizontal straight line up to the point C with negative sign. Next, at C a load is there, hence we have to take a section XX over here, and we have to plot, we can plot like this. This is the section, 7 kilonewton, 12 kilonewton, 13 kilonewton. Visualize 7 upward, minus 12 downward, plus 13. So 20 minus 12, 8, positive sign. So here suddenly changes and VHU as it 8. Between C and D there is no load. Shear force given by horizontal straight line. 8 sudden changes there with the plus sign. This is my basic shear force diagram that we achieve over here. Let us go for bending moment diagram. Before we proceed for the bending moment diagram, let us look it out the basic principles or basic rules that we fetch up over here. First, between 2 point load there is no load. The variation of shear force diagram given by horizontal straight line. At a point load, shear force diagram suddenly changes. Now let us plot for bending moment diagram. We have taken the 3 different sections. First, between A and B we are carried out one section. So this section is over here. This is X. What is bending moment? Bending moment is defined as algebraic sum of the moment of the forces. So on the left of the section only a single force is acting. This 7 kilonewton create a moment at section XX is of 7 into X. Force multiplied by perpendicular distance. So 7 into X is the bending moment at XX. So if we take another page over here, if we add up another page over here, then bending moment at XX is equal to 7 into X. This 7 into X is created section left clockwise, hence positive.